Hi, my name is Assan, and I'll be speaking to you briefly about derivatives. And the first thing we're going to talk about is differentiation rules. Okay, so first of all, a derivative is the slope of the line tangent to a curve. And you'll usually see derivatives written as f prime of x or dy over dx. Okay, but first of all, the first rule we're going to talk about is when you just have a constant. To find the derivative of a constant, that's just any number. So if you have like f of x equals 0, then the rule is that f prime of x is also going to equal 0. But a better example of that is, let's say you have y equals 4, and like I said, another way to represent the derivative is dy over dx, then the derivative of 4 is still 0. So basically, if you don't have an x in the equation, when you find a derivative of just a single number, it's always going to be 0. Okay, so the next rule we're going to talk about is when you have a constant raised to a power. So the rule says that if f of x equals x raised to a number n, then f prime of x, the way you find that is you put the n in front of the x and then you subtract 1 from the n. So the actual rule is n times x raised to the n minus 1. An example of that would be if you have x raised to the 4th power, then the derivative of that is addition and subtraction 4x raised to the 3rd power. So you brought the 4 in front of the x and you subtracted 1 from what it was originally raised to. So subtract 1 from 4 and you get 3. Okay. The next rule is when you have a constant multiplied by something else. So f of x equals c times x. How you get the derivative of that is you leave the constant, whatever it is, and you take the derivative of the x and you multiply that by x. So it's c times the derivative of x times x. So an example of that would be y equals 5x raised to the 4th power. So the derivative of that, 5 is your constant here, so you just have 5 times, okay, take the derivative of all of this right here, of the x raised to the 4th power. And use what I just told you about a constant raised to a power. So you just bring the 4 in front of the x, and you subtract 1 from what it was originally raised to. So you have the constant 5 times 4x raised to the 3rd power. Where you multiply the constant times all of that, then you get the final derivative, which is going to be 20x raised to the 3rd power. Okay, now when you have to do with a derivative, that just means that all you're going to do is take the derivative of everything separately and add or subtract that all together. So if you have x cubed plus 2x minus 5, then use all the rules that I just told you about to find the derivative of that. So you take the first term, x cubed, you take the derivative of that. And remember, you bring the 3 out in front of the x and you subtract 1 from this 3. So your derivative for that is 3x squared. Your second term is 2x. The derivative of that is just going to be 2. Then you have your constant 5, so the derivative of that is just 0. So it's just 3x squared plus 2 minus 0. That's your final derivative. And here is an example again. If you have 3x squared, then you bring this 2 out in front and you multiply that by your 3 to give you 6, and you subtract 1 from this 2, which is going to be 1. So you end up with 6x. Then you have plus 2x. The derivative of 2x is just going to be 2. So your final derivative is just 6x plus 2. Okay. Those are some differentiation rules. Keep going. So now we're going to talk about the product rule and the quotient rule. So we can talk about the quotient rule first. The quotient rule says that Okay, to find the derivative, all you're going to do is, okay, u and v are differential functions of x. So if it's u over v, then to find the derivative of that, it's v times u prime, which is a derivative of u, minus u times v prime, which is a derivative of v, all over v squared. In simple words, that just means the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay. The example we're going to use for that is if you take f of x equals x squared minus 1 over x squared plus 1. Okay, so the first thing you want to do is your denominator times the derivative of the numerator. Your denominator is x squared plus 1. Your derivative of the numerator up here from the rules I just told you about, you just bring the 2 in front of the x, subtract 1 from this 2, so you just end up with 2x. So your first part is x squared plus 1, the denominator, times the derivative of the numerator, 2x. Okay, second part is you want to subtract the numerator times the derivative of the denominator. So your numerator is the x squared minus 1. So write that down, minus x squared minus 1. Then you take the derivative of the denominator, which bring the 2 in front of this x, subtract 1 from this 2. It's going to give you 2x, and since this is just a constant 1, it's just going to be 0. So the first part of the rule is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And this is all of that right here. All over the denominator squared. The denominator is x squared plus 1, so it's just x squared plus 1 squared. Right. Then you want to do all this multiplication in the top, and x squared plus 1 times 2x is going to give you 2x cubed plus 2x. Okay. Subtract x squared minus 1 times 2x from that, and you get 2x cubed plus 2x. And you just leave your denominator what it was, which is x squared plus 1 squared. Okay. So when you do all the simplification, yeah, you can leave it there. When you do all the simplification, you see that 2x cubed minus 2x cubed, those cancel out. So now you're left with plus 2x, which is 4x. And you can just leave your denominator what it was, which is x squared plus 1 squared. So your final derivative of f of x equals x squared minus 1 over x squared plus 1 is going to be 4x over x squared plus 1 squared.